Well, hello and welcome to this exercise on HCF or GCF and similar triangles. Now, these questions are from a past examination paper. There's nothing new here or exciting. You probably know them already. Well, what I'm trying to point out here are the pitfalls you might encounter in an exam situation. Now, here's the first one. It says find the highest common factor of A and B, or you might call this the greatest common factor, same thing. Now, what I've done here is to expand my numbers, so it will be 2 times 2 times 2 for 2 cubed, and then 3 times 3 times 3 times 3 for 3 to the power 4, and then 5 to the power 16. That this will be horrendous to expand there, so I leave it there. Now, similarly for set B, I've got this here. Now, to find the common factors, I'm going to group common numbers. For instance, I'm going to group those 2 because that's got a partner there. 2 has got another 2 there, so they've got a partner there, and so on. So what I've got is this one here. So I then bring this 2 down. So that's one set of 2, of the set number 2, and then another set of the number 2, and then another set of the number 2 there. Okay. Now, this 2 hasn't got a matching 2 there, nor this one here. Now, this 3 has not got a matching pair there. It's not got a matching pair of 3 there, but those 3 numbers do match. So I then bring that down, and then the product of these numbers will be 2 cubed times 3, and that's 24. Then, what do you do with 5 to the power 16 and 7 to the power 12? Now, if you raise 7 to the power n, where n is a positive integer, the last digit of such a number will end in either 7 or 9 or 3 or 1. Now, for that to be a factor of 5, it has to end in either 0 or 5. But this ends in 7, 9, 3, and 1. So clearly, these two numbers, 5 to the power 16 and 7 to the power 12, do not have any factors in common. So we stop there. Now, just to point out, do not confuse 7 times 5 or 5 times 7 as the same as 7 to the power 5 or 5 to the power 7. I hope that makes sense. Next slide. Right, now this is the second exercise, and again it's from an examination question, and it's got these two similar triangles there. We're supposed to find things like x and y and z. Yeah. This is simple enough. The trouble is that most of my students got this wrong, or some of them got it wrong, because there are little nuances there that they could not place properly when it came to doing the question themselves. Okay. So what I've done is to redraw the triangles and then do some relabeling as well. So it says AB corresponds to PQ. So I've named this line there A prime, B prime. There. And then it says BC corresponds to QR, and I've labeled QR as B prime, C prime there. So it says find X. Now, makes life so much easier now because we know X is at the point B, so that corresponds to the point B prime there. So X is 63 degrees. Okay, now we're supposed to find Y. Using ratios, if we do AB, which is now A prime B prime, divided by AC, which is now A prime C prime, we have that Y will be Y over 5 will be 4, which is A prime B prime, divided by AC, A prime C prime there, 4 over 8. And that gives us Y value of 2.5 centimeters. And if it says find Z, now Z is B prime C prime, and Z will be 6 centimeters there. The equivalent of Z will be 6 centimeters there. And I've done Z over 8, and 8 is A prime C prime, so 8 to be, sorry, for the little triangle to be AC there. So Z over 8 will be equal to 6 over 5, which is that over that one there. 6 over 5, 6 over 5 there. So Z is 9.6 6 or 9 3/5 centimeters. Now, I'm aware that it can find Z by using a cosine rule, because it can work out this angle here, and then using cosine rule it can find Z. Well, that would be, I don't know, that would be a bit more difficult, I think. But yes, you can do that by using cosine rule. I hope all that made some sense, and please subscribe. I hope that's been useful. Thank you for watching, and bye-bye.